Hello, my name is Nattakit Patcharapairoj. Student ID 6522781739.
Hi, my name is Aritsara Sermsathonsawat. My student ID is 6522771177. So today I'm going to present Micropoly. What is Micropoly? Micropoly is an innovative board game enhancement tool designed using Arduino. Inspired by a classic game Monopoly, Micropoly adds interactive digital features to elevate gameplay and increase player engagement.
How we combine Arduino IDE on it? Let's see. For the concept explanation, we implement core features of an ordinary board game to be more efficient and more variety, from having to carry a deck of cards and follow the repetitive game challenge to be generated and displayed on an LCD monitor. Not only that, but also the geo detection feature that helps detect and keep track the player in jail using our tools. For our first function, challenge block, is introduce minigames when player land on challenge block that test quick thinking, memory, and binary decimal conversion skills. Second is pick a card, is randomized instruction using an LCD when player land on it. And last one is jail time detection, is detect the player presence in a jail block using an ultrasonic sensor and alert them with a buzzer if they are not physical there.
Next, circuit and code description. Here is our main component used, including ultrasonic sensor, buzzer, Arduino Uno, buttons, LEDs, wire and breadboard, 4x4 keypad with expander, and the last one is LCD display, 20x4 with I2C modules. These main components have different purpose. So we're going to start with Arduino Uno. It's used for main controller. LCD, used for display messages and game output. Ultrasonic sensor, used for gel detection. 4x4 keypad, used for player input. Buzzer, used for audio feedback. And LEDs, used for correct and wrong answer indicators. Buttons, used to trigger random mini games, card draw, or even to activate gel detection. And the last one is breadboard and wires, used for circuit assembly.
Next, circuit description. First one is LCD and PCF8574 module connected to Arduino via I2C to Arduino Uno for displaying message, instruction, and game content. Next, ultrasonic sensor placed near the jail time block to detect if a player token is present. Buzzer activated with different tones for correct, wrong, or warnings. 4x4 keypad used for player input during minigames. And the last one, red and green LED, give instant feedback on player answers. Next is the part of code description. It is written in Arduino IDE with some logics inspired by AVR programming that utilizes example like melee-based timing for countdowns, implement external interrupt for geo detection, uses serial communication, interface with the keypad draw PCF 8574 I2 square expander, control the LED and buzzer using digital input output functions, use some digital for button and sensors, and employs the liquid crystal I2 square library to communicate with the LCD screen.
This section set up the core components for Micropoly. We include library for I2C communication and the 20x4 LCD display. Then we define the LCD and the keypad, which use a PCF8574 I2C expander. Next, we assign pin number for ultrasonic sensor, buzzer, LEDs, and switches. Include a gel switch connected to interrupt pin. Finally, we declare key state variable to manage button press, gel mode, and timing, and list all function prototype used throughout the program.
Next, startup animation for loading process bar. I get this code from the internet. I already give the credit. Let's see how it works. At first, make the arrays and register the character into the LCD memory to make it can drawing. Print the micropoly loading like the picture, and then set the process bar by bar length, step, delay. Then first for loop is for filling the black color into the bar, and the second for loop is for after fill all the black color into the bar. Then print ready.
In the setup function, we initialize all components. When the system starts, we begin I2C communication for the LCD and keypad. Turn on LCD black light and display a custom loading animation. We also set the pin mode for ultrasonic sensor, buzzer, and LED. The button use internal pull-up resistor to keep the default state high. An interrupt is attached to the gel buttons, so whenever it pressed, it instantly triggers gel detection mode using toggle gel detection function. Finally, we set all keypad pins to inactive, show Micropoly ready on the screen for 3 seconds, and clear the display to begin.
Next, random card function. We put the check card draw function in the while loop to make it can do over and over again. At first, we read the current state that is low or high. And then if the current state equal to low and last card switch equal to high, it means button press is detected. We clear the LCD, print drawing a card, and then pick a random number between 1 to 20 and call getCardText function that store the randomized card that we make and then display on the LCD.
Next, this code handles Micropoly minigames. In check minigame trigger function, when game button is pressed, it randomly selects one of 3 games. Memory games function show a 3-digit random number sequence, then check if the user entered it back correctly using keypad input and a 10-second countdown. Then for quick math function, it generates a simple math problem like adding 3 numbers and then check the user answer. And the last one is binary to decimal, display a binary number and expect the correct decimal input. All user input are time limit using function like wait for a key with countdown function and read number input with countdown function. Also the results are shown in show result function. For this part, control the 4x4 keypad using PCF 8574 I2C expander. The key map defines what each key does. The write PCF 8574 and read PCF 8574 function handle communication with the keypad via I2C at address 0x02. In scan keypad function, each row is pulled low one at a time and the columns are read. If the button connect at low row to a column, it means the key is pressed. The function returns the matching key based on the key map. This method saves Arduino pins while still reading all 16 keys.
Next, countdown logic and result display. For the first function, wait for key with countdown is wait for a single key press from the keypad, display a countdown timer on the LCD during the wait, and call time is up after no key press. And next function, read number input with countdown, is let the user input a number using the keypad, show the type number on the LCD. It supports an enter key using hashtag, and it time out if input is not completed. And last function is show result. It displays feedback on the LCD for right or wrong answer. Green LED on and short beep from buzzer is mean correct, and red LED on and longer beep on the buzzer is mean wrong. And 2 seconds is resetting the screen. Next part is gel detection function. We put it in the while loop because it responds by updating the display and resetting the LEDs. For the first statement, gel toggle flag is display the toggle state on off on LCD. And if gel detection is turned off, it's turned off white and red LEDs, and the buzzer will not alert. For next is gel distance monitoring statement. Is check the gel detection distance every millisecond by calling the measure distance centimeter function that we will talk about it later. And if the gel detection is on, we will look in the next if statement, that is if the player token's distance is less than or equal to 5 compared to the ultrasonics, the white LED will be on, red LED will be off, and the buzzer will not alert. It means that the player token is on the gel. Else, if the player token is off gel, the white LED will be off and red LED will be on, and the buzzer will alert. Next code is for the interrupt for toggling gel detection. When it triggers, it toggle gel detection mode on off and set a flag. And the last one is measure distance centimeter function. It's used to average the duration and convert the echo time into distance in centimeters.
After that, we have wiring summary. LCD display 20x4, So the component that we have is VCC, ground, and SDA, SCL. As normal, we have to connect VCC with 5 volts, ground with ground. And after that, we have to connect SDA with analog pin A4 and SCL with analog pin A5. Keypad for time flow metric, we have PCF8574. So first we have to locate the address of PCF8574 first, which is 0x20. Then we connect VCC and ground. SDA will connect to A4 and SCL will connect to A5. And keypad rows will be P0 to P3 and keypad columns will be P4 to P7. Next is the ultrasonic sensor. After we connect ground and 5 volts, we connect trig with pin 11 and echo with pin 10. Next one is buzzer. We connect positive pin of VCC to 5 volts. We connect negative pin to pin 12 and we connect ground to ground. For LED, we have green LED, red LED, white LED. It will be connected to pin A0, A1, D9 respectively, and all LED cathode will be connected to the ground. The button and switch. For the game trigger buttons, one leg will connect to pin A4 and another will connect to ground. For card draw buttons, one leg will be connected to A3 and another leg will be connected to the ground. And the last one, cell mode toggles buttons, one leg will be connected to pin 2 and other legs will be connected to the ground.
How Micropoly help in the game? Let's start with our gameplay flow, pick a card, jail time, and game challenge. So this is our project demonstration. It consists of many components including ultrasonic sensor, LCD, the buzzer, wiring, keypad, expander, switch, LED, a resistor, and the Arduino Uno board. So let's start with our gameplay flow. For the first one, if a player lands on a pick a card, player then press the second button. The LCD display a random instruction like pay 20 to each or miss 2 turns. It will be random.
Next is the game challenge. When the player lands on the game challenge block, LCD will display one of 3 mini games: green LED and buzzer for correct answer, red LED and defense tone for wrong answer. So the first game is Quick Math, a simple addition problems. You will have 10-second timer start using internal timer logic, and player have to answer via keypad. Next will be the second games, which is Remember or Memory Challenge. LCD will flash 3 numbers quickly. Player must recall and enter the sequence in order. If you answer wrong, the LED will show red and also the buzzer will alert. The last game is Binary to Decimal. A binary number will appear. For example, 1100. Player have to convert to decimal within 10 seconds. If you cannot answer within 10 seconds, it will consider as wrong.
So the last one is if a player landing on a jail times, player need to select the first button. It will activate the jail detection. Ultrasonic sensor detect presence. If no player is detected, buzzer will alert like this. But after the player token is placed, the detection, the buzzer will stop alert. And after the player get out of jail, the player need to select the first button again to turn off the jail detection. Next, about the credits. These are the credits that we use for our projects.
Our contributions to make this project. This project reflects a personal synthesis of theoretical and practical knowledge learned across multiple lectures in class CSS 332 or Microcontroller and Applications. Micropoly is invented on the observation that the current way of playing Monopoly requires many components that may have loss over time, and the current challenge and game flow can be predictable. We want Micropoly to enhance the experience of playing board game to be more interesting and feel refreshing every time. Hence, we come up with different features to integrate embedded system into real-world fun, blending learning with entertainment through a familiar board game environment. Thank you for watching our videos. We hope you had fun with our Micropoly board game enhancement tools. Thank you.